All right, what up? 30, 60, 90 triangles. One of the hardest concepts ever in the history of geometry. 30, 60, 90. It's known as a special right triangle because it has a certain special facade about it. I don't know. But it follows this template. Now, if y'all are ever writing a paper or doing a resume or something, you're going on Microsoft Word and you're going to pull a template that you want to use because you want to use what's already available to you. This is what this is. This is a template. I'm going to show you what it looks like. So here's a 30, 60, 90 triangle. Okay? The side length across from a 30-degree angle is always going to be x. Just follow me here. The one across from 60 is going to be x times the square root of 3. And the one across from the 90-degree angle, which is the hypotenuse, is going to be 2x. So what this means is, as if I know what x is, I know what all the sides are because I can just plug x in where that stuff is. So for example, if x was 2, then that would mean this side length down here would be 2, which would mean this one would be 2 times the square root of 3, okay? And then this one would be 4 because 2 times 2 is 4. So that's kind of how that works. So what I want to do is I just want to do a couple problems with you, okay? The goal is to always set up an equation and then solve for x. Once you get x, you plug it back in. All right, so let's do a problem. So number one, draw this triangle. It's a 30, 60, 90. I have a 30-degree angle here. I have 6 here. I have x, and I have y. Now, what those x and y really mean is just those are the things I want to find. So don't get confused with, hey, I have an x over here in this template, but I have an x over here, because that's not what that means. This x over here is actually just referring to, I need you to find it. So I need you to find this side length, I need you to find this side length, okay? So it may be even better if you just would ignore those x and y's. You may say, why am I even putting them there? Because a lot of times you're going to see stupid problems like this, and I would just do something like this and say, okay, I know I need to find this side and I need to find this side, okay? So I'm going to use the template, okay? So I know that there's a 30 here, that means I know there has to be a 60 here, okay? So using this template over here on this side, the one across from 30 is x, so I'm going to say this equals x. The one across from 60 is x square root of 3, so I'm just putting the stuff on the triangle. And then the one across from 90 degrees is 2x. Okay, so if you look, I have an equation. And it's actually already solved for. So that means since x is 6, I can take that and plug it in where I see all these other ones. So since x is equal to 6, I can take 6 and I can plug it in where I see x. Okay? Which means that this side length right here is going to be the same as 6 square root of 3. Okay? And this side length over here is going to be the same as 2 times 6, which is 12. Okay? So all I did was take x and plug it in where I see x. Now, again, these are just variables, and the reason why I didn't write them over here is because they do get confusing. I don't want you to worry about it. Those are the side lengths you're trying to find. So if you get a problem like that, just draw a triangle, draw the same triangle, and just eliminate those two variables. Okay, and then just know that you have to find them. All right, let's do another problem. So number 2, let's draw this one. Okay, I got a 30-degree angle right here in this corner. I have 14, and I have x, and I have y. So again, the x and the y represent the side lengths that I'm actually trying to find. Okay, so what I'm going to do is I'm just going to come over here and I'm actually going to redraw that triangle again. This time just leaving out that x and y. So I have a 14, I have a 30, I have my 90-degree angle. Since 30 is there, that means I know 60 goes here because it's a 30, 60, 90. Now, I'm looking for these two side lengths, right? So again, we're going to use our template and we're going to see what we know. All right, right now I know 14 because I had to have something. I have 14. 14, when I go over to this template, represents which side? Well, it represents the one across from the 90-degree angle. So therefore, this guy is actually 2x. And so I've created an equation. The one across from 30, right here, is x. And the one across from 60 is x square root of 3. I have an equation. You should always have an equation. Whether or not it's solved for, well, that just kind of depends, right? So on the first one, it was solved for already. On this one, it's not. So what I'm going to do is I'm going to pull this equation out, and I'm going to look at it. So 2x equals 14. How do I solve for x? Well, I divide by 2. So x is going to equal 7. So now I know what x is, and I know where to place it. I place it where I see x. Boom, right there, and right there. So that makes this actually equal to, this y right here is 7. Because see, I'm just putting x in there for it, right? And this one is 7 times the square root of 3. Okay? Don't round that out. Leave that 7 square root of 3. I think that's just easier, okay? So there's our another problem, okay? Again, we're just using the template. Let's do one more. All right, I got a side length of 8, and I have a 60-degree angle. And I'm looking for x and y. All right, so again, I'm just going to redraw this triangle. Okay, I'm going to redraw it. Let's pick a different color here. I'm going to redraw it over here so that I can eliminate those extra variables I don't need. All right, I know 60 is here. I know 8 is here. I know I need to find these two side lengths. I know this is 30 because it's a 30, 60, 90 triangle, right? Okay, now, real easy, we're going to look at the template again. So looking at the template, I have the one that's across from 60, right? So when I look at the template, the one that's across from 60 is x square root of 3. So that's what I set that equal to. The one across from 30 is x, and the one across from the 90-degree angle is 2x, okay? So notice I've changed my triangles around, I've moved them around, but reality is the template's there, and you always look for what's across from that particular angle, okay? What side length is across from that angle? All right, do I have an equation? I do. This one. Kind of weird, I know. Let's pull it out and look at it. Okay, what this says is 8 is equal to x times the square root of 3. Now, the square root of 3 is just a number. I know they get kind of like, blows your mind a little bit. You're like, I don't want to think about roots. But it's just a number. It's like if I said 2, 2 is a number. So to get rid of this square root of 3, I just have to divide it off. And when I divide that off, it'll go way over here, right? And that'll be left with x, I'm just going to flip this around, equal to 8 over the square root of 3. Okay? Now, I'm not allowed to have a root in the bottom. So anytime you see like a root in the bottom of a fraction, you're not allowed to have that, which is called the denominator. I can't have that. And so to get rid of that, I just have to memorize that I'm going to multiply by that same root over that same root. Okay? So what happens is, and this is just a little trick, what happens is I'll have 8 square root of 3, and then this root will go away and I'll be left with 3. So if you have a calculator and you put 8 divided by the square root of 3 in your calculator, if you have one of the multi-view Texas Instruments, it will spit this answer out right here. But if you got another calculator, it may give you a decimal. We don't want a decimal answer. We want to have something that's an exact answer. So this is what this is. This is an exact answer. All right, so let me follow you through this again. So we divided by the square root of 3. Reason being is because we got to get rid of that. Once we divide by the square root of 3, to get rid of this root that's in the bottom, because we're not allowed to have a root in the bottom, we can have it in the top but not in the bottom, we have to multiply by the square root of 3 over the square root of 3. We have to multiply whatever's down here. So if it was like the square root of 6, I would multiply by the square root of 6 over the square root of 6. What happens is I'll have 8 times the square root of 3, and then the roots on the bottom will cancel out and create whatever's underneath it. So if there's a 4 underneath it, it'll be 4. Okay? If there's a 2 underneath it, it'll be 2. All right. So let's go back over here and fill in our template. So we know what y is. Y is going to be whatever x is, right? So when we got to throw this x in here now. So this is what x is equal to, okay? So what we have to do is we have to look at what we had. Our template is 2 times x. Since this is x, this is what I'm putting in for each of these parts, right? Okay? So this one's pretty easy. This one I don't have to do anything with it. So I know that 8 square root of 3 over 3 is going to be the same as this variable right here. But this one over here, if you look, I have to multiply it by 2. Okay? So that's the same thing as doing 2 times 8 square root of 3 over 3. And anytime you multiply something like that, you may be like, I don't know what I'm doing here. Well, all you got to do is take 2 times whatever the number is on the outside of the root. So 2 times 8 is 16. So I get 16 square root of 3 over 3. And so that's actually what y is. So y is going to be 16 square root of 3 over 3. And then you're done. All right, I know that that seems a little complicated, but to be honest with you, that's the easiest way that I've ever known to be able to do 30, 60, 90 triangles. All right, see you later.